All right, perk problem 7. We're given this huge mess of a polynomial and asked to do a bunch of stuff with it. Part A says explain why x equals 3 is a possible rational root of this polynomial. The reason why is because the rational root test says that factors of the constant term 135 divided by factors of the leading coefficient, which is 1 in this case, are possible rational roots. Something to that effect is perfect. I guess you might want to show that 3 really is a factor of 135 because 3 times 45 is 135. But I don't know. You don't really have to put that. Part B, it says test this root, x equals 3, to show that it actually works. So, okay, we can do that. Might want a calculator for this part. But let's see, our polynomial f of x is x to the 7th minus 5x to the 6th plus 11x to the 5th minus 15x to the 4th minus 9x cubed plus 45x squared minus 99x plus 135. So to test to see if 3 is actually a root, what we try to do is figure out what is f of 3. I don't know, it equals something. I mean, you can put it all in. Should end up getting 0. Kind of shortcutting this because I'm lazy. You might want to do more work there, or you could leave it just like that. f3 equals 0, therefore 3 is a root. Good enough, I guess, if you're a little bit lazy. Use polynomial long division. So maybe I'll do that over here. To factor out the factor corresponding to this root. It's a little bit wordy, but what it's trying to say is divide x minus 3, be careful there, it's not x plus 3, into x to the 7th minus 5x to the 6th plus 11x to the 5th minus 15x to the 4th. I really should have chosen a smaller polynomial. Minus 9x cubed plus 45x squared minus 99x plus 135. Alright. Need an x to the 6th up here so that I get an x to the 7th down here. And then when I subtract, negative 5 minus negative 3 is the same as negative 5 plus 3, which is negative 2x to the 6th. So then up here, to get rid of the negative 2x to the 6th, I need a negative 2x to the 5th, because that times x gives me negative 2x to the 6th, and that times negative 3 gives me positive 6x to the 5th. Then I subtract. So 11x to the 5th minus 6x to the 5th is 5x to the 5th. Maybe I'll bring these down in every step, although you don't need to. Maybe less likely that stuff will get lost if I bring everything down. So I got 5x to the 5th and then the rest of this stuff minus 15x to the 4th minus 9x cubed plus 45x squared minus 99x plus 135. Alright, so now what I need to do is put something up here so I get rid of 5x to the 5th. And what that something is 5x to the 4th. Gives me 5x to the 5th. And if I multiply that times negative 3, I get negative 15x to the 4th. And now I can subtract. These cancel out, and I'm left with just negative 9x cubed plus 45x squared minus 99x plus 135. So now I want to get rid of this 9x cubed. Negative 9x squared gives me negative 9x cubed plus 27x squared. Subtract 45 minus 27 is 18. X squared minus 99x plus 135. Oh man. Then I want to get rid of this 18x squared. I need an 18x. That gives me 18x squared, and then 18x times negative 3 is negative 54x. If I subtract, I get 45x plus 135. Negative here. Negative 45x. I'm going to get rid of negative 45x. I need a negative 45 here. And hopefully I'll end up with no remainder here. Negative 45x, negative 45 times negative 3, sure enough, is positive 135. I get a 0, no remainder. I'm happy. Although I'm going to run out of room. Okay, so I used polynomial long division, and I got that f of x was equal to this times this. Maybe I can jump over here for part D. So I got f of x is equal to x minus 3 times x to the 6th minus 2x to the 5th plus 5x to the 4th minus 9x squared plus 18x minus 45. And then the hint tells me to factor this out using factoring by grouping. And so the way I'll do that is I'll look at these first three terms, and what they have in common is an x to the 4th. And if I pull out that x to the 4th, I get x squared minus 2x plus 5. And to be left with an x squared minus 2x plus 5, I'd have to pull out a negative 9 from this side. And then I'd be left with x squared minus 2x plus 5. So what I have is this is x minus 3 times x squared minus 2x plus 5. Factor that out from each of these terms. And left over is x to the 4th minus 9. And then this I can factor even further. X to the 4th minus 9 is a difference of squares. It's x squared minus 3 and x squared plus 3. And then I still have this x squared minus 2x plus 5. So that's as far as I can factor things. So what I'll do next is I'll find all 7 roots of this polynomial. So I should say that's as far as I can factor things for the meantime. But I think eventually we'll be able to do a little bit better. So to find all of the roots, this one's easy. It's when x equals 3. These ones, so x minus 3 equals 0 gives me x equals 3. X squared minus 3 equals 0 gives me x squared equals 3. So x is equal to plus or minus the square root of 3. X squared plus 3 equals 0 gives me x squared equals negative 3, which gives me x equals plus or minus the square root of 3 times I, because it was the square root of negative 3, so I can pull that I out. Alright, and then this last term, x squared minus 2x plus 5 equals 0. Because I got a little bit of room down here. I can complete the square and get x minus 1 squared minus 1 plus 5 equals 0. X minus 1 squared plus 4 equals 0. So x minus 1 squared equals negative 4. X minus 1 equals plus or minus the square root of negative 4. X minus 1 equals plus or minus 2i. So x equals 1 plus or minus 2i. So what I get is 7 roots. Here's 1, 2, 3, 4, 5, 6, 7. Okay. Where to go from here? Check one of these roots. Check one of the complex roots. Find f of the square root of 3i. I picked one of my complex roots here. I'm going to figure that out. I know that f of x is this mess. So f of the square root of 3i would be square root of 3i to the 7th minus 5 times the square root of 3 times I to the 6th plus 11 times the square root of 3 times I to the 5th minus 15 square root of 3 I to the 4th minus 9 square root of 3 I cubed plus 45 square root of 3 I squared minus 99 square root of 3 I plus 135 square root of 3. Nope, 135. That's all. So I need to figure out what this mess is equal to. Maybe I'll pause the video and do it here because that'll take me a little while. Well, I'll just do it. Screw it. So the square root of 3 raised up to the 7th power is the square root of 3 times the square root of 3 raised up to the 6th power, which is 3 raised up to the 3rd power, which is 27. So the number I get here is 27 root 3. And then I to the 7th, I'll end up with an I. I to the 4th is 1. So it leaves me with I cubed. Here's one of those i's, and then the I squared makes this thing negative. Square root of 3i to the 6th is the same as 3 cubed, which is 27. 27 times 5 is 135. So my number here is going to be 135. I to the 6th is negative 1, but this negative cancels it out and gives me a plus 135. Root 3i to the 5th is 9 root 3, which times 11 is 99 root 3. 99 root 3, and then I got I to the 5th, which is the same as just I. Alright, root 3 I to the 4th, 9. Root 3 to the 4th is just 9. 9 times 15 is 135. Yeah, 135. So I got negative 135. And then I to the 4th is just 1. Root 3 I cubed is 3 root 3. 3 root 3 times negative 9 is negative 27 root 3. I squared makes that positive. So that gives me positive 27 root 3 I. It's a little bit small. Maybe I'll write that down here. Plus 27 root 3 I. Um, 45 root 3 I squared. Root 3 squared is 3. 3 times 45 is 135, and I squared makes this negative. So I get negative 135. You can kind of see what's going on here. These are all going to cancel out. Negative 99 times root 3 is just negative 99 root 3. And I still got that I. And then plus 135. If you add all those up, you get 0, which means that this is, in fact, a root. Finally, almost done with this part G. I have to write this in its factored form. So G says f of x equals, and then I just want x minus each of the roots. So x minus 3, x minus plus or minus, where am I here? Root 3. So x minus root 3, x minus negative root 3. Now I got plus or minus root 3i, so x minus root 3i, x plus root 3i. Still not done because I got to multiply those by these last two roots down here. Got 1, 2, 3, 4, 5. The last two are 1 plus or minus 2i. So x minus 1 plus 2 root I, or sorry, 2i. And then x minus 1 minus 2i. Wow. All right, that is finally the end of this problem.